Ni live. Now it's live.
Nah, okay.
Now it's live. The broadcast is live. Okay, let me start
Hi,
over.
good evening to all
Hi.
students. Welcome to
Oh,
Pusat Tuisyen AYU, and a joint venture and with EDD Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let us begin with our session with the recitation of your prayers according to your religion. Okay, how is everyone doing today? I hope everyone is doing fine and ready for today's lesson. I am teacher Eileen as the moderator for today's class, and together with me is our control host, Madam Hafsah Ayu from SMK Sultan Sulaiman Kuala Terengganu. And also together with me is our observer, Madam Zanelia binti
hi.
Abdullah. Okay. And of course, our presenter, Madam Rosmaya binti Mokhtar from SMJK Yuhua Kajang. Okay, welcome everyone. For your information, we are now live on Madam Rosmaya's channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel as well as teacher Hafsa Ayu and Tegusana and myself. Okay, so as usual, the lesson will last approximately for 1 hour. Please follow the class until the end and please give your full cooperation in making this class a lively one. Please take note that the certificate link will be given at the end of the session. Besides this, the link to claim the credit for today's live class as well as the presenter's username will be given too. Don't forget to claim your credit. Please accumulate the credit points to redeem the attractive prizes prepared for you. However, for a 4-digit code is needed to claim the credit. The code will be revealed 1 digit at a time during the live class. So please be alert and get ready with your paper and pen. I would also like to remind students to use appropriate language and profile picture if you wish to post comments in the chat box. I am pretty sure all the students here are excellent students who will uphold a positive classroom environment. Stay focused, and if you have any questions, please write on the chat box. Madam Rosmaya will try to provide you with the answers. So without any further ado, so please welcome Teacher Rosmaya.
Okay. Hi everyone. So my slide is here. Okay, so before we start, I am Rosmaya Mokhtar. Welcome to my channel. Okay, so before we start, I'm going to introduce our physics, the team in Academy YouTuber. Okay, we have physics team. Okay, we have chemistry team, biology team, and chemistry team, maths team, and also the accountant and economy team. So for physics team, I am the leader. Okay, I'm the leader. Then we have here teacher Ayu. Teacher Ayu is with us here. Okay. Teacher Ayu is, where are you? Up me, okay, on top of me. Okay, we also have Teacher Su, Teacher Suhaya, Teacher Nun, and Teacher Rashida. Okay, and maths team. Okay, we have lead by Teacher Team. Okay, and we have also with us here, Teacher Eileen and Teacher Zanaria. Teacher Eileen. Okay, bottom me. Okay, we have Teacher Eileen and Teacher Zanaria, part of the members in the maths team. Okay, lead by Teacher Im. Okay. Then we have biology team lead by Cikgu Faiza. And we also have chemistry team lead by Cikgu Shahnon. And lastly, perakaunan dan ekonomi lead by Madam Fizi. Okay. So without further ado, we continue with our discussion today. Okay. So our topic today still in the magnetic fields topic. Okay. The subtopic is determination of specific charge Q per m of positive charge particles. So the objective for our lesson today, our discussion today is students should be able to describe the motion of a charged particle in the presence of both magnetic and electric fields, where V, B and E perpendicular to each other. And also we are going to solve a few problems given. So the problems are given already in the description part. You can get from there. Okay, so before we start again, we need to recall what we've learned before. So what we've learned before, we've learned that you must know that when a charge pass through electric field, okay, like this, the first picture here, when the let's say the positive charge, okay, pass through electric field. So what happened to the charge? The positive charge will attract to the negative plate. So what happened? The direction of force is towards the negative plate. So the path followed by the charge here is parabolic path. Okay, this is what we've learned before. And also when the charge pass through a magnetic field, so what happened in the previous discussion, okay, so what happened, the charge will follow a circular path. Okay, so the direction of the force can be determined using Fleming's left hand rule. Okay, so if you refer to the diagram here, north to south shows by the forefinger, and the middle finger shows the direction of motion of the charge here, or the V direction, and the thumb shows upward direction. So this positive charge will follow a circular path in the magnetic field here. So this is what we've discussed before. Now in this discussion, what happened if the charge is in both, in the presence of both electric field and magnetic field? Okay, so to discuss on that, we will be we will discuss when the using the instrument used here. Okay, one of the device used is called spectrometer. So this is the spectrometer 3D diagram. We have a few compartment here. Okay, the first one, and then the second one, and the third one. We are going to discuss on how the flow, okay, the flow of the charge here through the spectrometer. So I will convert this diagram to the 2D diagram, like this one. 2D diagram better, same as just now, but this is 2D diagram. Just now is 3 dimension for easier to discuss. Okay, so we have the first compartment here where the container here, we put a gas. Okay, the gas is in the container here. Okay, the gas at low pressure we put here. Okay, then what happened? The cathode here means emits electron if we complete the circuit here. So the thermionic process from here. So the electron will attract to the anode at a very fast velocity. Okay, fast electrons collide with the gas inside here. Okay, what happened? The gas inside here, the container, will be ionized by a beam of electrons. Okay. Then what happened? They are in the next compartment. We have a plate Z and Y, plate Y and plate Z. Okay, so the plate Y will be slightly negatively charged. Why? Because we are going to draw out the charge inside here. So if we are going to draw out the charge, positive charge, so what happened? The plate Y must be negatively charged. We are just going to draw the positive charge ions to the what they call this opening here, to the opening here. So that's why Y is slightly negatively charged. Okay, then the charge, the positive charge leave the chamber here. Okay. Okay, next, when then the ions are going to enter the region here, the slit S1, pass through the slit S1. Okay, so what happened? The charge, when it enters the magnetic field here, so the direction of the magnetic field here, dot means the direction of the magnetic field is out of the screen. The dot drawn here, so means that the direction of the magnetic field is out of the screen. So we use Fleming's left hand rule to determine the direction of the force experienced by the charge, positive charge, when it enters the magnetic field. Okay, this compartment. Okay, so the direction of the V, okay, the charge, positive charge coming out from this opening S1, okay, is upward, shown by the middle finger. Okay, then the direction of the magnetic field is out of the screen. So your forefinger must be in this position, and the three fingers must perpendicular to each other. So the force, the thumb shows the force direction is to the right. So what happened? The charge will flow. Will flow in a circular path. Okay, circular path, and it will reach here. Okay. So the shape is a semicircle of radius R. Okay, this radius R. So this is the chamber, tube light. Okay, so we can adjust the V here. How to make sure that it the charge can manage to reach the opening here S3. So the charge actually flow through opening S1, or we call this slit S1, S2, and then S3. So to make sure that the charge reach the collector here, okay, we call this collector. So we can adjust the V. Okay, V is adjusted until we can manage to see the reading, observe the reading from the microammeter. So this means that the charge managed to reach S3, pass through S2 and then pass through S3. So the current flow. So we can get the reading from the microammeter. Okay, so this means that the ions have gone through S2 and S3. Okay, next.
Okay, thank you, Rosmaya.
Yes.
How about we review the first code?
Okay, I forgot about thank you for reminding me, Teacher Aileen. Okay, so our first code is A0. Okay, A0. Jot that down, and wait for 3 more digits. There are 5 digits for the code, for the credit code. Okay, so wait for 3 more. Okay, so we continue. Okay, next discussion is we are going to derive the formula, okay, for a specific charge Q per M. Okay, so we are going to determine the specific charge Q per M for the positive charge particles. So we start with the principle of conservation of energy. Okay, principle of conservation of energy, where the change in kinetic energy is equals to the work done. So the work done is QV, and the change in kinetic energy of the charge from 0 rest to the maximum V velocity of the charge coming out the slit 1 just now. So we use principle of conservation of energy, half mv squared equals to QV. So we rearrange this equation, we get V equals to square root of 2 QV per M. Okay. So next, we also going to use centripetal force. Centripetal force is provided by the magnetic force. There is no other force involved. So the centripetal force is provided by the magnetic force. So the magnetic force for a charge is given by QVB. Okay, all this we've discussed in the previous lesson. So magnetic force equals to QVB. We substitute into here, so we get QVB equals to mv squared per r. Okay, cancel the v. So we get QB equals to mv per r. Okay, then we squaring both sides because we are going to substitute the v above into here, the equation here. So now we can substitute the b above into the equation here. So we squared because we don't want the square root. Okay, then we rearrange the equation and cancel out the m here. What else? We can cancel one of the q here, and we rearrange the equation. We get q per m. So q per m is the specific charge. Q per m is the specific charge. So given by 2v per b squared r squared. Okay, so this is the specific charge by calculation from the schematic diagram just now. Okay, from the diagram just now, okay, the B, the R, and the potential difference across the two plates here, okay, can be measured. So therefore, we can get the specific charge Q per M. All this can be measured. Okay, so this is derivation of the first equation. Okay, specific charge Q per M. Okay, so look at this is the actual the real spectrometer. There are many types actually spectrometer. So given in the diagram here is two type of spectrometer. Okay, so we are going to next discuss on the specifically on the mass spectrometer. Okay, mass spectrometer. So the schematic diagram, okay, is like this. Okay, for mass spectrometer, the difference, the basic diagram, schematic diagram is the same. They are only different because of this part is velocity selector. So we discuss on mass spectrometer first before we solve a few problems. Okay, this is mass spectrometer. Means that we can determine the mass of the ions. Okay, mass of the ions. Okay, let's say the chamber here, this is the source of positive ion. Let's say we put here. So this is the collimator slits where we adjust the potential difference across these two to draw out positive ions from this container. Okay, then we are going to bring it to make it the ions flow through the next division. Okay, velocity, we call velocity selector. So this velocity selector has a combination of electric and magnetic field. This part we call this part as a velocity selector. Okay, next is the plate here. Okay, this is another chamber. Then the plate here is a photographic plate, so that we can detect the ion that reach the plates here. Okay. Then we have the last part is the uniform magnetic field B. Okay. So before we do the calculation part, we discuss part by part, these two part lah, especially these two part. So we discuss the velocity selector to get the mass of the spectrometer, which is given by mass of the ions given by QB squared R per E. Okay, M equals to QB squared R per E. Okay, so this part in the form 3D diagram. Okay, this is the 2D diagram. So for easier discussion, I redraw this as a 3D diagram like this. Okay, 3D diagram. So now the electron, the ions in the chamber flow through the velocity selector. This compartment we call velocity selector. So it consists of electric field and magnetic field. combination of electric field and magnetic field. Okay, so if we refer to the magnetic field, refer to the magnetic field only because we use Fleming's left-hand rule. Okay, in the presence of magnetic field only. So the V is this way, and the B is from north to south into the screen. Okay, and then the thumb shows upward, so that means the force is upward. Like you see just now. Okay, the charge here, positive charge will follow circular path, so upward. So FB we label as upward. Okay, another force that act on the charge here is in the presence of electric field only, so it follow the projectile path. Okay, projectile path. Okay, because the positive charge attract to the negative plate. So therefore, the path followed by the charge is parabolic path if the charge is in the presence of electric field only. Okay, then these two forces that act on the charge, if we switch on both for magnetic force and the magnetic for electric field and the magnetic field, so we have two forces act on the charge. If they are balanced, means the charge undeflected, so it follow a straight line. Okay, follow straight line. So that's mean the magnetic force equals to the electric force. FB equals to FE. So FB magnetic force is QVB and FE electric force is QE. So we can cancel out the Q. So we get velocity of the ion, the ion just now, positive charge, let's say, okay, equals to E per B. So this is called selected velocity. So we can calculate the selected velocity by using this formula E per B. So we can adjust the E and B. This is the 2D diagram. This is the 3D diagram. So for 2D diagram, you can see the electric field and the magnetic field. So we can adjust so that the charge flow through undeflected path, means a straight line. So that it managed to pass through this slit, the first slit to the magnetic field chamber. Okay. So we keep for a while this selected velocity because we are going to use this later to derive the mass of the charge, the positive charge just now. Okay, so next we are going to enter the next part, compartment. So this is the velocity selector. So the what you call the slit just now, the slit we call this time the slit is S3. So it coming out, the charge coming out S2 through S3, then enter the magnetic field, uniform magnetic field chamber here. Okay, so this part now. Okay, for this part, we use centripetal force concept because the charge when enter the magnetic uniform magnetic field, so what path followed by the charge? So it follows circular path, right? So therefore, we use centripetal force. We use centripetal force. So the centripetal force is equals to mv squared per r, and it is provided by the magnetic force. Remember that electric field is no longer applied here. Okay, so we only apply the magnetic field here. So FB equals to mv squared per r. So FB is QVB, okay, equals to mv squared per r. So we rearrange the equation here to get m. This is our target to get the mass, right? So mass equals to QBR per V. QBR per V. Okay, so we are going to substitute this V into here. Okay, so we rearrange the equation here. So therefore, we get this mass of the charge just now, positive charge entering, coming out from the container here. So proven the formula for mass of the ionized atom. Just now we discussed is a positive charge. Okay, so now we can compare if the gas here contains more than one kind, That means it contains isotopes. Isotopes, let's say 1, 2, 3. The gas contains isotope 1, 2 and 3. So what happened after it pass through this slit S3? So it will follow 3 circular path because of different mass. Okay, the 3 isotopes of the gas just now has different mass. So therefore, they will follow different path. Okay, so this is what the mass spectrometer do. So we let's say here we can detect from the photographic plate here 3 isotopes. Okay, from ions of different isotopes follow different semicircular path. Let's say the D1, from D1 we have R1, D1 per 2. For D2, we get R2, D2 per 2 or half D2. And finally, D3 is half D3 because we are going to substitute into the equation here to get the mass for the first isotope. Let's say M1 equals to QB squared R1 per E. And then the second isotope, okay, so we substitute R2 into here, which has mass QB squared D squared per 2E. And finally, the third mass of the ions, we have Q B2 D3 per 2E. So this is the explanation from the mass spectrometer, example of the mass spectrometer from this schematic diagram. Okay, so done for this one.
Okay,
So
Madam
now,
Rosmaya.
okay.
Okay, I think we take a break.
Okay, 30 minutes already. Okay, we take a break.
Before that, we can. Madam Rosmaya, the second.
Oh, the code. Okay. Thank you for reminding me. So the second code is, where is it? Okay, number 9. The second code is number 9. Okay.
Yes.
Berita baik untuk
Hafsa. Iklan, please.
Iklan.
Press 1 only.
berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, we are back.
Okay, welcome back. Thank you, Teacher Eileen. So we continue. Okay, we continue with the questions now. Okay, the question actually given already in the description part below. So the first question we are going to we read first together the question. Okay, in Bainbridge mass spectrograph, okay, a potential difference of 1000 volt is applied between 2 plates distant 1 centimeter apart. And in magnetic field B equals to 1 Tesla. So the velocity of undeflected positive ions in meter per second from the velocity selector is, okay, so what are we going to do to, which formula to be used? Yeah, we derived a few formulas just now. So which formula to be used? Okay, hopefully you remember the formula. And okay, very good. Someone has answered here already because I leave the question just now, right? Okay. So we can see, okay, all of you, Chia Hao Sing, Chia Chong, Valamati, Ganesan, Hong Fan, okay, all of you got C. Okay, very good. So let's discuss the First, determine what is given in the question. We have 1000 volt. This is the potential difference. And the distance apart is 1 centimeter. And then the B, 1 Tesla. Okay, so the V, one of the formula is, the V we derived just now is E per B, right? Okay, so how to get V per B? Sometimes this is objective question. You can directly use the formula. But what if in the essay question? So we discuss this question in terms if it is question. This question come out in the essay question. So always start with the beginning here. So magnetic force equals to electric force because of it managed to flow out through the selector, the opening, so that it managed to enter the chamber just now with the magnetic field, uniform magnetic field. So we use Fm equals to Fe. So QVB equals to QE. V equals to E per B. Sometimes you forgot the formula. It's V equals to B per E or E per B, right? So this might help you. Okay. So sometimes in the middle of the exam, you will get confused whether to E per B or B per E. So always start from the beginning so that you know which one is on top, which one is at the bottom. Which one is at the numerator and which one is the denominator. So V equals to E per B, but E is not given, right? This one relate also to the previous chapter. We discussed electric field, the first chapter, or chapter 12. E equals to V per D. So you substitute V per D into here, then all the values given. 1000 volt, potential difference, B 1 Tesla, and then the distance between the plates, don't forget to convert to meter, convert to meter. So it's correct. So you all get C as your answer. Okay, so this is considered as warming up exercise. Okay, so we go to the next question. Okay, next question. Okay, let's read first the question. The mass spectrometer shown below has a velocity selector that allows ions traveling at only one speed. Okay, from the velocity selector here. Okay, one speed to pass with no deflection through slit S2 at the end. Okay, so it managed to pass through slit S2. While moving through the velocity selector, the ions pass through an electric field E 60,000 Newton per Coulomb and a magnetic field B1 0.0500 Tesla. So determine the speed of the ions that are not deflected. Okay, the A, very easy. Okay, you can, as we discuss, you those who can do now. Then we do the question B. After leaving the velocity selector, the ions move in to a new magnetic field, B2, 0.0600 Tesla, and determine the radius of the curvature R of a singly charged Q equals to 1.6 times 10 to the power of negative 19 Coulomb. So this is the charge given. Then this is a lithium ion. With mass M equals to 1.16 times 10 to the power of negative 26 kilogram. Okay, so what's the answer for A? So anyone can try, it's very easy. A, direct question. So determine the speed V of the ions that are not deflected. The keyword is are not deflected. Okay, any answer?
Okay, students, write down your answers.
I'm waiting here. Very easy, it's direct question only. We just do question 1. Those who can do question 1, actually you can answer the question 2A already.
Don't worry, just try. Yeah. If wrong, it doesn't matter. No problem if you get wrong. Yeah.
Okay, we have here Jia Hao Seng. Okay, Jia housing 1.20 times 10 to the power of 6, okay, meter per second. And then Chai Teng Suan also, okay. So let's check the answer, whether you got correct or not. Okay. So very direct question only. We can always start from the beginning, as I mentioned just now, if you forgot the formula, whether E per B or B per E, right? So you can cancel, QVB equals to QE, cancel the Q, so we get V equals to E per B. So substitute 60,000 Newton per coulomb, and then the B is 0.0500 Tesla. So it's correct. So it's 1.2 times 10 to the power of 6 meter per second. So this is the velocity or the speed of the ions. They are not deflected. Okay, so we keep this in A. So next we go to question B now. Okay, very good. Very good. So you all got correct answer. Very good. So let's try question B now. Sub question B. Okay, now after leaving the velocity selector, this is the velocity selector, the ion now move into the new magnetic field. So the magnetic field dot here means that the magnetic field is out of the screen. Okay, given 0.0600 Tesla. So determine the radius of the curvature R of a singly charge. Charge is given here 1.6 times 10 to the power of negative 19 coulomb. And then the mass also given 1.16 times 10 to the power of negative 26 kilogram. So what is the radius from the previous equation that we've discussed? So which formula to be used? Sometimes more than one formula needed. So for this type of question, actually, you should do, it's better to do from the beginning so that you don't have to memorize so much. So always start from the beginning. There are three equations, basic, start from the beginning, which is Fm equals to Fe. What else? The electric field, and then from the magnetic field. And then we have the centripetal force, and also from the what you call that, conservation of energy. Three basics physics rule that we use. Okay, looks like we have one answer already from Chia Hao Seng. 1.45 meter. Okay, very good. So let's check the answer. The rest of you can continue doing, okay, while we discuss here. Still can write there in the chat box. Okay, so we can, because the keyword here radius, right? The keyword here radius. So if radius, that means we use centripetal force. Centripetal force is provided by the magnetic force. Okay, so F equals to QVB. So the magnetic force is given by QVB. Okay, then we rearrange the equation here to get R. R equals to MV per QB. Okay, so now we substitute all the values given. Okay, we can use the V from A. So that's why the question asks A first. A. Okay, so the answer is 1.45 meter. Okay, very good. Correct your answer, Chia Hao Seng. What about the rest of you? So did you get the same answer? It's still okay? You still can write there in the chat box saying that you get the same answer. Okay. Okay, now we go to the next question. Remember that always start from the beginning, because here the marks marks usually not just one mark. There are 2 or 3 marks sometimes. So always start from the beginning. Okay, don't directly use the formula. So remember the 3 rules that we use. We use centripetal force, and we use the magnetic force equals to the electric force. Okay, then the last one is the principle of conservation of energy. Okay, the 3 physics rule we use. Okay, let's try the third question. Okay, third question. Okay, question 3. Okay, we read the question first. A charged positive ion has a mass of 2.5 times 10 to the power of 26 kilogram. Okay, after being accelerated through a potential difference of 250 volt, the ion enters a magnetic field of 0.5 Tesla. So in the direction perpendicular to the field. Okay, calculate the radius of the path of the ion in the field. Okay, the charge is given, positive ion charge here is 1.6 times 10 to the power of negative 19 coulomb. Okay, so remember the three rules that we use. Okay, so try to answer. Make sure you show the steps clearly. First determine, check first what is given in the question. When you label what you've given in the question, sometimes might help you to answer the question also. Okay, this is one tips for you all. So you label in the questions what is given so that you, if you forgot the formula, at least it can memory might come back. Memory might come back if you label like this. Okay, what formula to be used. Okay, so you are given what? You are given the mass, you are given the potential difference and the magnetic field, the radius. You are going to determine the radius and the charge is given. So you can see B, R, M, V, Q. Okay, by looking at the letter here, symbol used, maybe your memory might come back from what formula to be used. Okay, any one of you can get the answer. Those who can manage to get the answer can write there in the chat box. I repeat again the three rules that we are going to we use in this chapter. Fm equals to Fe, balance the magnetic force and electric force, and then the second one is the conservation of energy. Okay, and the third one is the what is the third one? I forgot already. The centripetal force. Okay. So we have answer from Tia Housing 1.77 centimeter. Okay. So let's check. The rest of you, okay, Chai Teng Xuan. Okay, in meter 0.0177 meter. Okay, so let's check. The clue here is radius. Radius. Once you see the word radius here, that's mean centripetal force involved. Remember the three physics rules. So the centripetal force is provided by the magnetic force. Okay, magnetic force is given by the QVB. Okay, always show these steps. Always show these steps because this is essay question, a subjective question. Okay, so subjective questions are very important to show the steps. Okay, then you rearrange the equation because we are going to determine R, right? So R equals to mV per QB. Okay, so we have problems here that we don't know V, right? Like the question 2 just now, they guided you question A and B. So they asked you to find A first. But this time the questions didn't give direct you to ask A. So you need to do the more than one step here. So we don't know V. So we need to calculate V first. Okay? So to those who cannot get the answer, remember this. But it's okay because you still got marks for this one. And to get V, we either use, remember the three rules just now, we either use the principle of conservation of energy, or another one is the balance the force by the magnetic force and the electric force. So this one, these two, which one to be used depends on the what given in the question. So which one to be used? So let's check. If you use Fm equals to Fe, which is QVB equals to QE, so E is not given in the question. So we cannot use this one. Okay? So we use the principle of conservation of energy. Okay, so from the principle of conservation of energy that we discussed just now, this one comes from the change in kinetic energy. So it's converted to kinetic energy, and also it's the work done here actually from the supplied voltage. V equals to Q times V from the work done. QV equals to change in kinetic energy, which this equation comes from the principle of conservation of energy. So we use this instead of Fm equals to Fe because electric field not given. Okay, so now the V equals to square root of 2 QV per M. This capital letter V for potential difference. So while M discussing values given. Okay, so we get the V is 56,568. It's okay for you to answer the significant figures here until more than 3 because we haven't come to the final answer yet. So you are allowed to use more than 3 significant figures. So you substitute into here and the final answer must be very careful. So you can write in 2 significant figures or 3 actually. Look at given information given, all in 2 significant figures. So that's mean final answer you may write 2 or 3 significant figures. So I write here in 2 significant figures 0.018 meter. So it's also correct if you write 1.77 centimeter Jia housing, and another student Chai Teng Xuan 0.0177 meter also correct. Okay, good. Okay, so let's try the next question.
Okay, Madam Rosmaya, before we proceed, let's reveal the third code.
Okay, so the third code, let me check first. The third code, okay, the third code is number 4. Okay, jot that down to claim your credit. This is actually the 1, 2, 3, 3 digits. 3 digits. So another 4 digits already. 4 digits already. So 1 more digits to go. At the end of the class later. Okay, so we continue with the fourth question. Okay, fourth question. So an electric field is produced between 2 parallel plates which are 2.0 centimeter apart by applying a potential difference of 8,000 volt. So a magnetic field of 0.042 Tesla is applied perpendicular to the electric field. A beam of ions traveling with a velocity v enters perpendicularly into the combined fields and passes through undeflected. Okay, this is the keyword here, undeflected. Then find the velocity of the beams of ions. Okay, so what is the velocity of the beams ion? Okay, so try to answer this question. Actually, you can score these topics. It's very easy actually. Just remember the 3 rules we use. I repeat again, centripetal force sometimes balance the magnetic force and electric force. Another one is from the principle of conservation of energy. Okay, so and you can write there in the chat box. As usual, you can label what is given in the question. That might help you to get the what equation to be used in the exam. Because in the exam, the what formula not given. So by labeling like this, it might help you so that the memories come back for the which formula to be used. You are given D, you are given potential difference, you are given the magnetic field B, and then we are going to find the V, the velocity. Okay, Chia Hao Seng, 9.52 times 10 to the power 5 meter per second. Okay, who else? Gao Ming Chai, also the same answer. Who else can write them there so that we can have a comparison for the answer? But okay, very good. All of you get the same answer. Chia Che Chong or Chong Chia Che. I also don't know which one to pronounce first. Chia Che, 9.5 times 10 to the power of 5 meter per second. Okay, let's check the answer. Okay, so remember this for the undeflected positive ion here. So that means the force upward equals to the force downward. What kind of force is that? It's a magnetic force and electric force. Sometimes the question asks what kind of force mentioned. Magnetic force equals to electric force. Okay, so magnetic force is given by QVB and electric force is equals to QE. Then cancel the Q. So no need the value for the Q actually because we cancel out the Q and V equals to E per B. So, but the E again not given here. So you can use a formula V per D. So given V and given D here. Okay, so substitute these two values. And don't forget to convert the unit to centimeter to meter. And the answer, substitute into here. And the final answer, okay, is correct. Okay, 9.52 times 10 to about 5 meter per second. Okay, 4 questions already. So that's, I hope that all of you understand well how to get means answer this kind of question, right? Very easy, right? Yeah. Okay, so we go to the next question. And then check the significant figures. 2 given here. You are allowed to write in 3 significant figures. 9.5, right? Varamati, write into significant figures also. Can still get marks for your answer. But don't ever write in more than 3 significant figures. Okay, next. Okay, we read the question together. Figure 16.41 here, not mentioned here, but the figure below lah. So the figure below shows an electric field formed between 2 metal plates separated by 2 centimeter. Okay, and a magnetic field of 0.025 Tesla perpendicular to it. A proton traveling with a velocity 3.0 times 10 to the power of 6 meter per second enters the combined field perpendicularly and passes through undeflected by the fields. This is famous word, undeflected by the fields. Okay, mass of proton is given 1.67 times 10 to the power of negative 27 kilogram. So if not given, you can refer to the data booklet given during the exam, or sometimes in your calculator also got actually mass of proton. Okay, so this is the what you call this the constant values given. Mass of proton 1.67 times 10 to the power of negative 27 kilogram. So find the electric field strength between the 2 metal plates. Then what is the voltage between the 2 plates? And then calculate the acceleration of the particle when the electric field is switched off. Another one is calculate the acceleration of particle when the magnetic field is switched off. Okay, find A first. What is the electric field strength between the 2 metal plates? Okay, what is, you can write there. Okay, I know you are still doing. Okay, at that time you can label, okay, what is given in the question. You are given D, distance between the 2 plates. You are given B, magnetic field. And then the velocity of the proton. So what are we going to use? Okay, Ben answered 7.5 times 10 to the 4 volt per meter. And then the Yifan Wong, okay, 7.5 also same answer. Valamati Ganesan also same answer. Okay, let's check your answer. Okay, I repeat again the 3 rules that we use. We use Fm equals to Fe. Okay, this one. One more, centripetal force. If I mention radius, here not mention radius, right? Okay, another third rules we use is principle of conservation of energy. So remember these 3 rules we use for to solve this kind of question. Okay, Debbie also, Dylan Yap. Wow, so many get same answer. So the answer here must be the correct answer, right? Okay, so let's try. QVB equals to QE, cancel out the Q. So we get V equals to E per B. So this time we are going to find the E. So we substitute into the equation here. Okay, the V velocity and the magnetic field. So we get electric field 7.5 times 10 to the power of 4 volt per meter. So correct. Okay, so now what is the voltage? What is the voltage? Okay, anyone can write there. What is the voltage? So remember that once you get the answer A and you want that to answer in B, so usually this kind of question got A, B, C, D sub question. Usually they relate with each other. So even though you don't know how the answer for A, you must make use of A to answer the B, B or C or D, so that you can steal at least 1 mark using the answer from A. If you will do B, maybe you are going to use answer. Don't just leave your answer blank. Okay, we have here Gao Ming Chai, 1,500 volt. Okay, Tiu Ting, Chia Chia, 1,500. Okay, so all of you get same answer. So I can see here that many of you means understood. Hopefully you all understood very well what we've discussed here today. So voltage between the two plates. Okay, so we put here E on the A side. So rub this off. So the voltage between the two plates is E equals to V per D. Okay, so the E is this one, substitute E, then the distance to centimeter, convert to meter. So finally we get V 1.5 times 10 to the power of 3 volts. Okay, very good. You can answer in the standard form or you can write 1,500 volt. It doesn't matter, both accepted. Okay, then question C. Okay, question C, acceleration. What is the acceleration? When the electric field switch off and when the magnetic field switch off, C and D. Okay, calculate the acceleration. Okay, this one a bit means quite different from the all questions we've done. Okay, but can be what can be used, formula can be used here. Okay, so not given, not discussed in this just discussion just now. So a new formula. Okay, also you've learned before. Okay, also very easy actually. Okay, so anyone? What is the formula to relate with acceleration? Okay, we have Chia Housing here, 7.50 times 10 to the power of 12 meter per second Okay, Ben, 7.18. We have two different answers here. Remember to check. Ben 7.18, Gao Min Chai 7.19 times 10 to the power of 12. Okay, Gao Min Chai. Okay, who else? Okay, Yifan Wong. Okay, let's check the answer. Okay, the acceleration for C. For C. Okay, so we keep this V here for B and then we rub this off. So we do C. So we use F equals to MA because the force comes from the electric field. Provided by the electric field here means we use force equals to QE. So means the force provided here is electric field is QE. Okay, this one actually I do for D. Okay, this one actually do for D. I do wrongly. Okay, never mind. We do D. You can do D also, but I do typing error. Okay, I mean the slide, not typing error. I do D first actually. So the force come from the magnetic field here. Okay, remember this is magnetic field. So you substitute QVB. Okay. the charge given here. So you get A equals to 7.2 times 10 to the power of 12 for D question. Okay. Then for the C question, you use the same, F equals to MA also. So actually the right side is for D, F equals to QE. Okay. So this one for electric force, the right side for C, the left side for D. Okay. Okay, so QE, you substitute E electric field from A into here. Okay, so the M, the mass, so you got A. So do you realize that we have same answer? Okay, we have same answer. So for C and D, you are supposed to get same answer. Okay, so if you switch B, magnetic field, means in the presence of magnetic field, you got the charge experience, the acceleration, this value. And also when you switch off the, correct, because this one electric field switch off, right? Correct, very good, very good. So remember, if you are right, make sure you use this one, the correct one. Okay, I repeat, electric field is switch off. This I didn't realize here, switch off. Electric field switch off means the charge is in the presence of magnetic field. So force here is the magnetic field, QVB. Okay, this one is for C, and this one is for D, correct? Okay, D means magnetic field switch off. The charge is in the presence of electric force only. Electric force which is equals to QE. And both of them give you same answer. What might give you no marks is by this part lah. The physics concept used here, very important. If you substitute wrongly, which one for C and D, so you totally lost mark. Even though you get same answer, so must be very, very careful. Okay, so there are equals in value. Why is it there are equals in value? What can be concluded here? Because this F is the same, right? For the ion, for the proton to be undeflected, so this force, magnetic force and electric force is the same value. It's the same value, balance. Fm equals to Fe. So they should means have same acceleration A. Okay. So I think that's all the 5 questions. Okay, we have discussed. So don't forget the next class, okay, for continue, we still haven't finished yet. This is for positive charge. So we need to discuss, the next one is for the electrons, ratio of electrons. So see you in the next class. That's all from me for today's discussion. So I give back to our moderator, Teacher Aileen.
Okay, before this, how about the final quote?
The final code. Thank you again, Teacher Aileen. I always forgot about the code. Okay, so the last code is what is the number 2. Okay, the last code, number 2. So complete.
All right. Yeah. So now we have reached the end of today's session. So thank you so much to those who are able to follow our session from the beginning until the end. So before we end our session for today, and as a sign of support, please click the subscribe button below and activate the bell icon so that you will not miss the next class session. And then if you find that the lesson was beneficial, hit the like button and share to your friends on your social media. Spread and share the goodness. Now, the link of the certificate and the link of credit record, as well as the presenter's username, are already given in the chat box. Please take note the link will end 15 minutes after this live. Make sure using the e-didate email for the certificate and the correct ID e-didate junior for the credit record. Any incorrect email or ID used will not be entertained. If you don't have e-didate email or ID e-didate junior, please apply. If you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined eToday Junior Telegram, please do so. Before we end, I would like to thank all the students for joining today. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. I think that's all for now. See you in another session. Don't forget our hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next week. Same day, same time. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.